Welcome to Metrology lecture series. In the present video, we will discuss the interchangeable assembly and selective assembly. Let's see the interchangeable assembly. Interchangeable assembly means making machine parts so accurately and within tight tolerances that any part can fit with any matching part without doing any extra adjustment during the assembly. So in the interchangeable assembly, making the machine parts so accurately and with tight tolerances. Because of this accuracy and the tight tolerances, any part can fit with any matching part. So this is what we are calling as the interchangeable assembly. So let's see the example, nuts and the bolts. So in general, nuts and bolts are manufactured with standard sizes and tight tolerances. Because of this accuracy and tight tolerances, any bolt can fit into any nut, even if this bolt and nut are made on the different machines. So this is the perfect example of the interchangeable assembly, where one part can be replaced with another identical part without any problem. When many components have to be manufactured, it is not practical or economical for the same operator to make both the parts that fit together. In general, for the mass production, components of a part are manufactured by the different operators and the different machines. To save the money and time, industries use the mass production where different workers operate different machines to make the parts in the batches. Because of this, many people and many machines are involved. The sizes of the part must be controlled very carefully. So, each part is made within specific tolerance limits. So this ensures that when the parts are assembled later, they fit together correctly. When parts are made so accurately that any one part can fit with any matching part, even if both are chosen randomly, this system we are calling as the interchangeable assembly. So in the interchangeable assembly, while doing the fit of the any components, randomly you have to select any two mating parts. These two mating parts not making any problem while the fitting. So this is what we are calling as the interchangeable assembly. So the manufactured component under such conditions calling as the interchangeable manufacture. Let's see the example of a interchangeable assembly. Suppose a clearance fit is required between the mating parts with hole is specified as 25 plus 0.04 and 25 minus 0.00 mm and shaft is 25 minus 0.02 and 25 minus 0.04 mm. So here we require the fit is the clearance fit and given the hole and the shaft limits are given. So in this case, maximum permissible size of the hole will be 25 plus 0.04, which is the 25.04 mm, and minimum permissible size is the 25 minus 0.00, which is the 25.00 mm. So the dimensions of the parts produced, it will be lies between the 25.04 to 25 mm. So it will be lies between these two limits. Similarly, the maximum permissible size of the shaft is 25 minus 0.02, which is the 24.98 mm, and the minimum permissible size of the shaft is the 25 minus 0.04, which is the 24.96 mm. So the dimensions of all the shafts are produced. It will be lies between these two limits. So here whatever we are producing, the whole dimensions are the 25 to 25.04. Similarly, all the manufactured shaft size is the 24.98 to 24.96 mm. So therefore, even if we selected any hole at random and similarly any shaft selected at random, with these permissible tolerances, they will assemble with each other and will give the desired clearance fit. For example, randomly I selected the hole, that is the, let's consider 25.01, because all the holes are varying. So within the 25 to 25.04, let's consider its size is the 25.01. Similarly, randomly I selected the shaft, that size is the 24.97. Let's consider, because all the shaft sizes are the 24.98 to 24.96. Then in this case, the type of the fit of the 25.91 hole to and 24.97 shaft, it will be give the clearance fit. Similarly, I have to select the randomly I have to select any hole and randomly I have to select the any shaft. This will be give the clearance fit. So this is the example of the interchangeable assembly. So next we have to see the advantages of the interchangeability. So first one is the operator does not need to waste time and skill adjusting the parts by trial and error. So assembly process becomes the very fast. So in the interchangeable assembly, no need to for the any adjustment while the assembly. And let's see the another one. There is increased output with reduced the production cost. And third one is the, since the work is divided, the operator repeats the same limited task again and again. This means him skilled in the specific work and improving the quality and reducing the time required for the each operation. And moreover, interchangeable assembly allows mating components to be produced at different locations by the different operators. And one more advantage is the replacement of the worn out or defective parts and repairs becomes the very easy. And moreover, so while the interchangeable assembly, the cost of maintenance and shutdown period is also reduced to minimum. So next we have to discuss the selective assembly. Selective assembly is used in manufacturing when parts cannot be produced with tight tolerances. So instead of making all parts exactly the same size, the parts are measured and grouped into size categories. After that, matching the each part so that the final assembly fits correctly. So in the selective assembly, not making the parts with tight tolerances, but based on its dimensions, group the parts and make an assembly with respect to its sizes. So in the selective assembly, not select the mating parts randomly. We are making the assembly based on the dimensions. So in the selective assembly, the components produced are classified into groups according to their sizes by the automatic gauging. So let's discuss selective assembly with the one example. Let's consider piston and the cylinders, two mating parts, and here we are producing the sizes are with the high tolerances. So after manufacturing the piston and cylinders, we have to measure the piston size as well as the cylinder size. So first step in the selective assembly is the measure the parts. After measuring the dimensions of the piston and cylinders, we have to make the group. So small pistons making the one part and medium piston one group and large pistons making the another group. Similarly, small cylinders making the one group, medium size of the cylinders one group, large size of the cylinders are making the one group. After that one, we have to make the assembly by matching the sizes. Like we have to make a assembly small piston with the small cylinder. Similarly, medium piston with the medium cylinder, large pistons with the large cylinders. This make the correct assembly for the all of the groups. Let's see the example of a selective assembly. Let the bore size is 50 mm and the clearance required for the assembly is 0.12 mm on the diameter. Let the tolerance on bore and the piston each is the 0.04 mm and dimensions of the bore diameter is 50 plus 0.02, 50 minus 0.02 mm and dimensions of piston diameter is the 49.88 plus 0.02 and 49.88 minus 0.02 mm. So first we have to manufacture the bore and shaft as given the sizes. Then after that, based on its dimensions, we have to make the group. For example, bore is given the upper limit is the 50.02 and lower limit is the 49.98. So between these sizes, we have to make a one group, which means all the bore which having the diameter 49.98 is one group. Similarly, 49.99 is the another group. 50 mm is another group. 50.01 is the another group and 50.02 is the another group. Similarly, you have to manufacture the shaft within the sizes and based on its dimensions make you have to one group. Here piston upper limit is the 49.88 plus 0.02 which is the 49.90 and lower limit is the 49.86. So we have to make the group of the pistons based on its dimensions. So all the pistons which having the size is the 49.86 is one group, 49.87 is another group, 49.88 is the another group, 49.89 is the another group, 49.90 also making the another group. Now we have to make the assembly which will give the clearance exactly 0.12 mm. So you have to make the assembly 49.98 bore and 49.86 piston is make the one assembly. So here it will be clearance is the 0.12. Similarly 49.99 and 49.87 bore and piston make the another assembly. Here also it will be give the clearance is 0.12. Similarly 50 mm bore and 49.88 piston is making the another assembly. It is also give the clearance is 0.12 and 50.01 bore and 49.89 piston is making the another assembly. Here also it will give the same clearance, that is the 0.12. And finally 50.02 and 49.90 bore and piston will give the clearance is the 0.12. So here observe that one so we are selecting the piston and the bore not randomly. Based on its dimensions we are selecting and making them assembly. So this is the selective assembly. Let's see the comparison of selective assembly and interchangeability. In selective assembly, parts are graded into groups and matched during assembly for the best fit. In interchangeability, parts are manufactured within the specified limits, so any part can be fit with any other part. So matching is required in the selective assembly, but in the interchangeability, there is no matching is required. And manufacturing accuracy is the moderate in selective assembly, but in interchangeability, high manufacturing accuracy is required. And in selective assembly, so assembly time is higher, but in interchangeability, assembly time is the low. Similarly, manufacturing cost point of view, in selective assembly, lower manufacturing cost, but higher assembly cost. But in interchangeability, higher manufacturing cost, but lower assembly cost. So skill required point of view, skilled operator is needed to choose the correct matching pairs. So in the selective assembly, skilled operator is required for the matching of the pairs. But in the interchangeability, less skill is required for the matching of the pairs. In selective assembly is suitable for the small batch production and larger parts and cost sensitive production. But is the interchangeability suitable for the mass production and high volume production. And quality consistency point of view, selective assembly is the moderate and it is depends on the matching accuracy. In interchangeability, high consistency and uniform fit across the all units. So inventory requirement is required in the selective assembly for the separate storage for the different graded groups. But in interchangeability, simple inventory, only one set of the pairs. So this is the overview of the selective assembly and the interchangeability. Thank you.